NASA Hunch Lunar Wheels. My name is Matthew Cormier.
I'm Luke DeValcourt.
I'm Eric Brazil.
And I'm Austin.
Our instructor is Mr. Liberto, and this is Beauchamp High School. NASA has shown interest in building or inhabiting the moon, and we have come up with our own personal design of the lunar scooter wheels in order to maneuver the rough terrain of the moon.
So for our research, we come up with possible wheel types like the pneumatic wheel, the Curiosity road wheel, and the tank tread. Possible material types we have come up with was Kevlar, aluminum, titanium, and pneumatic. And then for my idea was to reinforce the Curiosity rotor wheel, which make it more suitable and to withstand most of the moon's atmosphere.
My design was basically taking that of a normal wheel and applying a basic spoke design. I got most of my ideas from the Curiosity rover wheel.
My design was that of a standard snowmobile almost, as it's used to maneuver a similar terrain to what I imagine the moon would be, having the cleats on the treads, a very springy, foldable system.
And my design was a mixture between the Curiosity rover wheel and the pneumatic wheel, just to better uphold against the terrain. So the criteria and constraints of our prototypes were flexibility in the spokes and the 100 pounds of earth weight, last 300 miles in rough conditions, hold up against lunar regolith, and be easily pushed on foot. Some of the constraints were it could be no larger than 18 inches in diameter, no wider than 10 inches, no suspension or motor. It had to have half-inch axles, withstand the vacuum of space, and uphold against high and low temperatures. When we were trying to choose a design, we made a chart and tried to figure out whose best would fit, and we came up with Luke's design.
So for our very first CAD model, we have something very rudimentary. It doesn't have any of the mechanical components. It's just the wheel and the gears. So ideally, we would like it to be made of aluminum and something like Kevlar, which is very strong in resistance and still has some stretchiness to it. For our first prototype right here, we have very simple cardboard outer layer with some Vex parts as our gears. It's held together with duct tape. It's very simple. For our prototype version 2, we wanted something that would last longer than cardboard and would have a better implemented cleat system. So we looked towards a already existing tank tread for something like that. For our materials, we have some 3D printed gears and sprockets. We have foam taken from exercise mat. It's still held together with duct tape. And we have the cleats are attached on there by liquid cement. So for our second prototype, we changed from a simple gear to a sprocket design, which we would later like to implicate a bike chain to help it roll better. On our second one, we used a more durable material. We added the cleats to it so it would better able to dig into the surface. And we have real axle to help it move better. Here's some quick testing of how it rolls. So that is a mixture of sand and diatomaceous earth. It rolls fairly well. There are some spots where it loses its traction, but overall, it rolls well.